identical resistors in an infinite grid. All square elements this is an infinite grid spreading throughout, and each element let's say this is an element PQ, and each PQ has a resistance small r. Each element, each side of the square has a resistance small r. Right? Now, I take any 2 points in this grid. Say a point A and a point B are 2 points in this grid. And I want to find the equivalent resistance across AB. I want to find the equivalent resistance across AB. Clear? Now look at this. It's as if when current enters A, circulates through the grid and then entirely passes through B, what's going to be the total resistance encountered? Right? Say each of these is R. Right? The objective is to find the equivalent resistance across A and B. Say the equivalent resistance across A and B is X. The equivalent resistance across A and B is, say, X. Right? Now, do you realize equivalent resistance across A and C would also be X? Across C and D will also be X? Across D and B will also be X? Yes or no? Which means now, to just simplify matters here, across A and C, the equivalent is X. Across C and D, the equivalent is X. Across D and B, there is an equivalent X. Yes or no? This is the reduction of the grid. This is the reduction of the grid. And the net of all of this across A and B must be X. The net of all of this across A and B must be X. Yes or no? So then, when current enters A and leaves B, the total resistance encountered must be X. The total resistance encountered must be X in this network. Yes or no? If the resistance across A and B is X, then across A and C, C and D, D and B will also be X. So I've replaced everything to the left of this by X, the entire grid, above this by X, to the right of this by X, right? That's simplification. And the equivalent across A and B must now be X. Right? Now, this R and this X in parallel, this R and this X in parallel, this R and this X in parallel, and these three in series, in parallel with this small r will give me X. Is it not? Which means now, these three are Rx by R plus X. Each of these are Rx by R plus X. And in series, so 3 times this. Plus, and in parallel with the small r, must give me X. Yes or no? Right? That means this into this divided by this plus this will give me x. And you can solve for x. You get a quadratic in x. And you'll get the equivalent resistance across A and B. This will turn out to be r by 2. Small r by 2 will turn out to be the solution to that quadratic. There are other ways of dealing with this infinite grid using KVL, KCL, which I want you to obtain independently also. You know, I could actually fold the circuit about this. There is symmetry. I could fold the circuit like this, and I'll get equivalent resistances R by 2, because all these R's would be in parallel and will give me an effective R by 2 resistance, which I want you to obtain independently. Think about it. But this for sure. Right? All of you understand then how to deal with an infinite grid, right? And deploy symmetry in an infinite grid. Clear? Now, yet another thing which I want you to understand in electrical circuits is what's referred to as the nodal analysis. The nodal analysis. In addition to KVL, KCL, the nodal analysis would again be a handy tool to obtain currents in various branches of a circuit. All right.